Hello. Last time we have learning about the history of embedded system, and from this class, from this lecture, we will start to design the hardware and the software. So the design is very basic. Don't worry. The design is just for the students who is unfamiliar with this sync chip microcomputer. Before we start a new lesson, we still need to finish some topics which are left last time. What is single board computer? Single board computer consists of, for example, CPU. This is CPU. Room. This is previous room. Many years ago, 20 years ago, we use room. RAM. This is RAM. RAM is a random access memory. Room is a read-only memory. And then there are I/O chips. This is I/O chips. So there are some encoder, decoder, intercoder, decoder is here. So you just know, how many components are consist of a single board computer. Right now, we needn't use this kind of structure. We just use one single chip microcomputer to process all the function. All these components are integrated into one single chip. Now let's discuss, let's learn the structure of the general structure of a single board computer. It consists of, first is crystal. Every computer every central processor unit need a crystal. And then there's a reset. This is reset. This is very necessary. So we will do the experiment after a while. The crystal and the reset. And here is the data bus. This is data bus. And then address bus, then control bus. So altogether, the processor have three kinds of bus. One is data bus, another is address bus, another is control bus. So when address bus is send a signal here, the room and the RAM will find its right data and then push the data on the data bus. And the control bus is used to control which chip need to select, which wire need to select. For example, if you want to read data from room, then RAM cannot send out data. Otherwise, the data bus will cause conflict. And this kind of structure is a traditional computer structure. However, for our nowadays design, we needn't add room, RAM, PIO chips separately. If you don't understand this structure, no problem. We will do from very beginning, step by step. So do not worry. You just understand, you just have some impression what kind of chip the processor needs. Although all these kind of chips are integrated inside one chip right now. This structure is more than 20 years ago. Next, we can see single chip microcomputer. Here is single board. Here is single board computer, and then later we the single chip microcomputer have emerged. So you can see here, this is a STC single chip microcomputer. This is an evaluation board. So in general, I just need to such a small chip to design product. For example, this very simple humidifier product, I use this kind of chip to design. So this is a very low price. This chip is in low price. It's fit for us to design those consumer electronic device, which have many limitations on cost. This is just an illustration. You needn't understand how it works. You will know how it works later, but I can just introduce what is the schematic. On the schematic, you can find the central process unit. Here is central process unit. Then the central process unit can have a button connected to CPU, and then it have a drive the mouse FET, and then the mouse FET again drive those inductor and the capacitor to make the device work. And here is the power part. The power part is used to convert 5 volt to 20 volt. You needn't understand, but I just say the main function. And here is VCC, which is generally 5 volt for MACS51. But for STM32, it's 3.3 volt. So in general, the schematic will consist several parts. One main part is power part. Another part is processor part. Then there are some mouse FET or inductor or capacitor. This electronic part are mainly revised according to different product. And here is a machine designed in MCS51. We will do experiment today, but we will not do such a complex experiment. I just illustrate. I designed this kind of machine, and this machine have exported all over the world by my customer. They have a factory and sell to many countries. This is ping-pong chaining machine. The characteristic of this kind of machine is you must control the cost of the component. This is a typically cost-limited product. Although in some places it's still very expensive, but actually the cost is very low. Here is a diagram, a picture of GSP. This is GSP, TMS 320. GSP is especially suited for design those product which process signal, do some algorithm. This is GSP. It have flash. This kind of format is flash. This is SDRAM or DDR. Here is DDR, and here is inductor. So this is GSP. This is SOPC. I designed this based on FPGA, and here is ARM processor. So ARM processor communicate with FPGA, and the program language for FPGA is Verilog. So if you want to design a processor, you can use Verilog to design a processor. If you want to design a special integrated circuit, you can also use Verilog or VHDL to design. Here's configuration chip, which store the configuration file on this chip. At the time power up, the file will download to the chip and then start running. If this chip have removed, this is just like a body without head. Okay, next we will talking about some topics which you very interesting. The average income of embedded engineering engineer in China. Nowadays, I say average, not in Shanghai. In Shanghai, embedded engineer is much more. The salary for embedded engineer is much higher than in other places of China. So in the average level, it's 10,000 to 15,000. This is the average. Sometimes 8,000 to 10,000. But it depends. In Shanghai, the average is yes, 15 to 20,000. For bachelor student, if they graduate from university, before COVID-19, the average price for embedded system is engineer is 8,000 to 10,000. But nowadays, because economic have some jobs, so the average is about 7,000 to 8,000. This is the embedded engineer income in Peking, China, capital city in China. The average is about 20,000. Although the 20,000 for those engineer, I found most of them can do nothing, just do some very basic developing. So you can see this is statistical data. On the average, so the company need engineer. Their experience is about 3 to 5 years. This is average. But because many companies cannot hire this kind of experienced engineer, so they have to hire some new engineer. So they only need 1 to 3 years. This is 36%. But overall speaking, all the company like at least bachelor degree. Some are master degree. If we are below bachelor degree, there's some problem, only 7%. But if you are PhD student or doctor degree, only 1%, because doctor degree, they like to work in a very big company. And also doctor degree, for doctor degree in computer science, it seems no embedded system practical experience. So most students for the doctor degree students, they haven't any too much experience compared to the bachelor degree student. This is in engineer income in USA, also embedded system engineer. The average salary is average income for 1 year is 95,000. It's much higher than China, but only several times. Okay, you need to. I listed this material. You need to download. I think our colleague have already sent you this information. So you just install the software, do some preparation, and download some data sheet. In general, the company, this is a company requirement. They need an embedded system. At the time, they hiring this kind of engineer. They just want to, for example, looking for professional embedded software engineer. They need to familiar with the development circle, life circle. And the ultimate goal is to create optimized hardware or software system. So here is the responsibility of the engineer. You can compare if you can satisfy this kind of responsibility. First is design and implement the software on embedded system. And these systems are used for production and commercial deployment. Because many companies, they have product, they have need to sell this kind of product and deploy it in some commercial area domain. And then engineer need to design. You should design the hardware, software, develop, and programming. And after programming, you need to test and debug. So this is a whole life circle you should familiar with. But in most cases, engineer is impossible to grasp both hardware and software. So in many companies, they will hire hardware engineer. Also, they will hire some software engineer. And then you should review some code and design, review others engineers' code and design. Maybe you will download some code from network and then review it and revise it and design to fit for and customize the code for your own hardware. And you also need to find to solve the stability and the scalability of the system. Sometimes system is unstable when it's running on the factory or running on the custom side. So you should make it more stable, more efficient. If the software is too slow, counter response the signal in time, so you should increase the efficiency. Then you need to integrate some hardware and software to new product. You also need to support and optimize some performance-based design. For some example, you design some I/O function to optimize it. And you also need to interface with the hardware design and development. If you are a software engineer, you need to discuss with the hardware and the engineer. If you both grasp software and hardware together, then you can open your own firm. You can open your own company. You can earn much money compared with those engineers only understand the software or only understand hardware. Because if you only understand the hardware, you have to pay money. You have to hire other software engineer to develop. In most cases, if the software engineer is unqualified or he is lack of experience, in most cases, the project will fail. So it's a high risk activity. Research and development is a high risk activity, especially in this domain. And access the third party and open source software. Sometimes when you're programming by yourself, you will spend a lot of time. So I suggest you need to access, for example, GitHub GitHub to download those software and revise those software and adapt those code to your own hardware. So here is a requirement and a skill. For example, bachelor degree in computer or engineering. You have some experience in developing and find a problem in the target hardware or software. You also have experience in C and C++. This is mandatory for embedded software engineer. You also should have some experience on real-time operation system. The real-time operation system is, for example, preemptive, multitask. This is not very difficult. Later we will learn the RTOS, real-time operation system, RTOS. You also need to familiar with some software tools. And defect tracking tool, this is find the hardware problem. You know, hardware problem sometimes needed to find assisted by the software. And you also need to understand those coding techniques based on operation system. I say real-time operation system. Sometimes maybe you use Linux. You should be familiar with Linux operation system. And also IP protocol. IP protocol sometimes like TCP/IP or some other integrated property protocols. And you're familiar with different interface and hardware subsystem. For example, gyro, which is used in airplane, gyro, and accelerator, which you used to detect humans running speed, running activities style. And you also need to you can have the capability to reading the schematic. You should understand how other engineer design the product. So you need to understand the schematic. And you also need to read the data sheet. You know, different components have different function. When I select, before I select a component, I will read the data sheet and find if this component can fit for my design. If yes, I will select this kind of component. However, I also will check if this component is sale on the market. If no one sell this component or the component have produced several years before, you cannot select this kind of component. So the last skill is you need to learn how to writing some, for example, software architecture. You should writing. Detail design. You should also writing. For some Western companies, they like complete document of design. However, document complete need many time. You have to spend many time on document preparation. So if for those ordinary project, we needn't write a document, but for formal, expensive project, you must write document. Okay, this is topics which left last time. From this lesson, we will learn how to design LED flash based on protues. So first, you need to install protues, and after you install, then you also need to install MDK ARM. This video, you can see this video. I can demonstrate. This is running on Proteus. Proteus is a virtual simulation platform. You can place the hardware on the schematic, and then you can program on kill, and then it will run. This is protues. So you just see how have an impression on how it is consist. It consists of two software. One is protues, the other is MDK kill. Here is an example.
In this section, we will learn a very simple application, drive an LED and read a button status. The LED is actually a diode. Its typical drive current is 20 milliamperes. However, some can operate at 5 milliamperes. White light LED voltage drops between 3.0 and 3.2 volts. And red light LED voltage drops between 1.8 and 2.2 volts. When the CPU 8051 power supply voltage is 5 volts V, the voltage on both sides of a white LED is therefore 5V3V equals 2V. Since there is a 200 ohm resistor, the current is roughly 10 milliamperes. The LED will be harmed if the current exceeds the allowed amount. Toggle the cathode between 0 and 5 volts to turn the LED on and off. On the diagram, the anode is on the right side of the LED and the cathode is on the left. Then we will learn CPU. According to the chip's datasheet, a crystal with a frequency of 12 MHz and 2 capacitors is required to be installed on the left side of the CPU of the single-chip microcomputer MCS8051. The MCS8051's reset voltage is a positive voltage. The capacitor attached to the reset pin is used to turn the device on. When the device is powered on, an initial positive voltage of 5 volts appears on the reset pin. After some time, however, a resistor linked to the ground causes the voltage to decrease to 0. Multifunction pins are found on the right side of CPU. The address mode of the 8051 is determined by pin 31, and if VA pulls high, the address bus is invalid. 8051 has 4 I/O ports P0, P0, P1, P2, P3. Each port contains 8 pins. Each pin can be programmed independently. In this schematic, P0.0 is connected to an LED, while P1.0 and P1.2 are connected to buttons. The button is pulled up by an external resistor. If the button is pressed, then the voltage drops to almost 0. And the code can find that the button status has changed and further drive the LED to indicate the status change. In the Proteus simulation diagram, the VCC and GND are not displayed. However, for the actual schematic, GND and VCC must connect to 0 and 5 volts.
Okay, we have see one example of how this most simple schematic design. Next, we will illustrate the most simple step-by-step method. We will demonstrate how to create a protues schematic and how to create a software framework based on MDK ARM, MDK K4 version. Here, we can see I create a new project, LED project. Then select at mail AT89C51. Then we need to press yes button, and a startup code will add automatically to the project. Then we create a main file. We saved it as main.c. Next, we add the file to our project. This empty file, we need to add it to project. Okay, next we will edit the file. The first sentence is include reg51.h. This is a header file. We must include this header file. And then we start our main function, void main. Then in protues P0.1, we connect to LED. So here we will define S-bit. This is C language for 51, MCS 51, so it's a bit different with the standard C language. We define LED denotes LED pin. Then we will connect two buttons to the port P1. Okay. P1.0. We denote it's S1. XOR with 0. Then S-bit S2 equals P1 XOR 2. So these two sentences will select the pin 0 and the pin 2. We will remove this S-bit after a while outside the main function. Then we will add a main loop. While 1, this is a main loop. If you don't write a main loop, the code will crash. So main loop is mandatory in our programming structure. We will drive a LED. Let the LED turn on and turn off. We will assign LED equals 1, means LED is turned off. Then we will assign LED equals 0, means LED turns on, because when left side of LED is high, there's no current passes through the LED. Only low voltage can have current passes through LED. Then we also need a delay function. I first add a delay function directory inside the while loop. After a while, I will remove the delay function. outside. We define unsigned int. So this sentence for rotation is just used for delay function. We will build the target. After build the target, we can see there's some error. So we need to troubleshoot the code. We need to find why it have some syntax error. Okay, let's remove this bit outside main function. Okay, let's compile again. It's a success. Then we need to generate hex code after a while. The hex code can be used to download to the processor. First, we can try to debug on the software directly, not connect to any hardware. So this is software simulation. You can see the code is running correctly right now. I add a LED to the watch window. In the right corner, there's a watch window. You can observe the LED status is changing. Next, we will upload the hexamer file to CPU. Then run simulation. You can see LED is blinking very quickly. Because the simulation time is different with actual real hardware, so the time, if you assign 2000 milliseconds, it's not actually 2000 milliseconds. You should aware this. Okay, I adjust the time. So delay time, I have adjusted. So the blinking is slowly. Right now, I stop simulation, and I want to change the code again. I want to remove the delay function outside. So define a delay function. Void delay. First, I will not put any parameter inside the delay function. Just make the parameter fixed. So in main function, I call delay. This is function call delay. Let's verify if it can work correctly. Okay, there's undefined identifier. So we need to move the unsigned int to this delay function. So we need to insert, copy, cut this sentence, place here. Okay, it's a successful compiled. Then upload. Okay, it's running. Stop. Next, we will change. We will insert the parameter. Because right now the parameter is fixed, we will change the parameter. So I define my delay variable. then replace with my delay. Okay, here we can insert our real parameter. Verify. We verify on hardware. Okay, it's running. It's blinking right now. We will revise code for some other time delay. Let's see. It's too fast. The problem is that the int 4000 have already exceeded the int scope. So we add long int. Okay, it's slow again. But be aware, this flash time is very different with the actual flash time according to running on hardware. This is not accurate at all. It's only running on simulator. For hardware, we are not allowed on precision, must vary precision. Next, we will add some function to button. We will learn how to read the button. According to the button we read, we will change the behavior of the LED. If you find there are some results is different with what you're thinking, you should find where the problem exists. Next, we define a getKey function. Read the key value. So we can define a getKey. The key value should be returned. So we have an int. The function will return int. If no key is pressed, the return value is -1. If key button S1 is pressed, here is button S1 equals to 0, means it have been pressed. Because the pin have a resistor pulled high, pulled to VCC. So if the button is pressed, the pin will go low voltage. If pressed, we will assign I equals 1. Else, if S2, the signal button pressed, we will assign 2. In the end, we will return I. Okay, right now we will insert a getKey function below main loop, while 1. The first sentence below while 1. We first define a key variable. We define a variable for key return value. Then we will assign key with key function. Get key. The return value will assign to key. Then we will judge which key have been pressed. If key 1 have pressed, if key have pressed, different key have pressed, we will make the LED toggle in different frequency. So we will define a delay value. The first default value is 100. We will import a delay value to this delay function. Then in the key if sentence, we will change the delay value. So if button 1 is pressed, the delay value is 1 second. If button 2 is pressed, the delay value equals 2 seconds, 2000 milliseconds. So key value is used to adjust the delay value. According to the pressed button, the delay value will be changed according to the pressed button. Okay, compile. After compile, we will load it to processor. Then simulation, run simulation. Then press different key to find if it is work correctly. We cannot press the two keys together, only one time a key. You can see the flash frequency have changed. Step. We will change a bit little of delay value to make it more clear. Let's see. Debug, simulation. Okay, it's more slow than before. Okay, it's obviously the blinking speed is different. Okay, next step, we will disable the default blinking because at the time it's power on. There's a default delay value. I do not want the LED blinking at the time power on. So we add a sentence, if key is not pressed, if key equals -1 means key is not pressed, then LED closed. So in this place, I add LED equals 1. Let's verify. Run simulation. Okay, no LED blinking. When push button, LED blinking. Push button, LED blinking in low speed. Fast speed. Okay, blinking shut off. It's satisfied our design requirement.郭老师，休息一下，要不？不要休息，那个这样啊，我这边，我看看啊，我这样还有一个东西没放，稍等一下啊，我还有一个视频，我还有一个视频哪里去了？好了。 我来打开吧。Okay, next I will illustrate the hardware. In protues, I open a project. I don't save this. The project I will send you after the class. I open LED blinking project. This is switched LED. Okay, this is a project. First, I need to interpret. Maybe you have some question about how the reset it works. So I need to interpret. 看看啊。Here is 5 volt. Here is to reset pin. On the right side of capacitor, it's connected to reset pin. And also there's a resistor pull down to the ground. So at the time you power on, this voltage is 5 volt. I write here, make it more clear. When the power is on, here's the capacitor. Here's the capacitor. Here's the capacitor. When the power is on, so 5 volt is added to the positive pin of this capacitor. And this is 5 volt. Then when we connect a resistor to ground, this is R, this is to CPU, RST. So at the instant time power on, here's 5 volt, then drop slowly, then drops to almost 0. When you press this button, there's a button added here. You press this button. Sorry, I can't write this. Just a button. When you press this button, this pin is connected to 5 volt. So CPU began to reset. After you release this button, because this resistor exists, so it's go slowly to 0. So here's the reset pin. We can see crystal. In general, for modern central process unit, they integrate some crystal inside. So you needn't add external crystal. But if you want the frequency more precise, you need to add the crystal outside. Sometimes you can remove this two capacitor. It can still run. But some cell, I found seldom. I found that if you don't add this two capacitor, it can't run. I mean, for the ARM processor, for MCS51, you can remove this two capacitor. It can still run. But the recommendation is that you should add two capacitor. Let's find another example. I open another example. We upload, we open LED. This example is I make LED turn on one by one. It will run in round robin mode. So we can see how it perform actually running. Debug. Run simulation. I haven't added the code to CPU, so it can't run it. So I need to stop it first. Then add. Click. Add the program file. You need to program the software first. So I add a project. Project. And kill. Then LED. Then object. Okay. LED.hex. Then click OK. Then you run simulation. Okay. Let's run one by one. We will find how the software is programmed. Okay. Open software. KMDK. You can install KMDK 5, version 5. But for MCS 51, version 4 is also no problem. You also can use version 2. Okay, I open project. Open a project. Project. Kill. LED. This is the project. Here, we first define a delay function. Here's a delay function. Then, delay function is the same as what we defined previously. Although there are some name is different, but the structure is completely same. We have two variable, two for rotation sentence, which make the delay more slowly. In general, if the NOP sentence is in MCS 51 is only 1 microsecond, based on the frequency. If the frequency is set to 12 megahertz, here, like we define the crystal 12 megahertz. So one sentence, the first one sentence is only need, especially for NOP, only need 1 microsecond. And then is the while function. In while function, we will turn LED on and off. Here, you can see this is hexamol. This is hexamol format, which means FE means what? FE means this is binary. So this is most MSB. This is LSB. So this denotes P 0.7. This denotes P 0.0. Here. This is 1, 1, 1, 1, 1, 1, 1, 0. So FE, when output FE, all the other LED is closed. Only this is low voltage. Only this pin is low voltage. So P0 can pull the low, and the D1 will turn on. So you must add X denotes hexamer. Then we delay some time. Then we will change the LED. This is also hexamer mate. This means FD means you can verify. Use calculator on the computer. You can use calculator. Then you can select programmer, engineer mode. And in this mode, you can select hexamer. Then you can input FE. You can see FE equals 1110. Here is 1110. Then you can try FD. FD. Here is 1101, 1101. So you can verify. So this is the second LED will flash. Here is the third LED. FB, you can see. What does FB mean? FB. Okay, 1011. You can see. Okay, here. It's FD. So you can write this one by one. Compile. Okay, let's upload. Oh. It's running. We can also change this format. FE, I don't want to write FE. It's too difficult to sometimes feels not very fit for our human beings in illusion. So I write P0 equals then not. This means FE, you can see if it's correct, can running correct. Oh, sorry, I need to add this. Okay. Running again. If it can perform correctly, yes, perform correctly. Okay, I will revise another code. I revise this code. I don't like this kind of format. P0 equals. Then I need to shift left. Then after shift left 1 bit, I make the not. You can find what is shift left. It means 0. Shift 1 bit left. So 0, 0, 0, 0, 0, 0, 0, 1. Then I shift left 1 to this place. Here is 0. And when I not, after I add a not, it's become 1, 1, 1, 1, 1, 1, 0, 1. Okay, press. Huh? Oh, I need to add this. Okay. We can try to see if it's running correctly. Simulation. Okay, it's running. Debug, stop. So you can change all other format. For example, this place, this is only 1, 2, 3, 4. I can add one by one. I don't like this sentence, then add one by one. Okay? You can do other example later. Okay, it's running. Then I want to make the code more. This code seems redundant. I don't like it. I want to make it more remove this redundant. So here we can revise the code. I add if 0. I invalidate this section. The whole section. I add if 0, then if, and if, and if. Okay. Then I will add a new. This whole section is invalidated. Right now, we compile. We can try. Load it to CPU. Debug. Run simulation. Nothing is running because I invalidated the whole section. Okay. We will add some smart code here. P0 equals, I copy this to this place. P0. Then I use a for rotation. I needn't for rotation. I just I use a for rotation. For I define a I variable. For I equals 0. Then I use a break. Initially, we needed to design P0. Okay? Oh. P0. Then delay, copy delay. So in this rotation, we only have very little sentence here. We can upload, running. Only 3 sentences I can run. Okay, remove, stop. We can remove this sentence. This seems also redundant. I remove it. Because at the first time, I equals 0, so that sentence needed to remove. Then we upload, running. Okay. If you want to change the direction of LED blinkings, we can revise the code again to make the shift right. Shift right. I shift right. I need to change this 80. Okay. Shift right. We can see if it can run it successfully. Shift upside. It's running correctly. You can also put this kind of blinking outside. For example, I can define a function void my blinking. Void my blinking. I just need to copy and okay, it can running. Then I call my blinking. In this place, I call my blinking. So this code is invalid, already invalid because if 0. The compiler, when the compiler sees if 0, it will omit the whole section. Omit the whole section. Okay. Running. Okay. So we have removed the blinking function outside. During the time you programming, do not put many code on the main function. Please use this kind of function. You define function outside, and in the main function you just place very little function. Call, for example, I just call my blinking. Only one sentence. Here, only one sentence while one, then my blinking. It's very easy. You can debug on software, on software simulation mode. Here is a debug step. Step over. We just need a step. Press step. You can see it step in. I step out. Step out. Step out means jump outside, out of the function. Then step over. Step over means the debug will not enter the function internal body. It's just execute the whole function and then next sentence. You can see step over. Right now, if I click step over, it will not enter into the function. You see? Because here have no other sentence, only while one, so it will always execute this. But I will enter, then I enter, step in, I will enter. You see, this is step in, enter to this sentence. Then here is my blinking. You can see, I will step one by one. P0, okay, delay, then P0, delay. You can see here, the arrow denotes which sentence is executed. You can see P0. I add P0 to watch window. You can see each time the value will change. For example, I step up. You can see GF, shift right, EF. So it's always change. If you step in, I can step into the delay MS. Okay, delay MS. Then I run. Then if I want to step out, you just click this sentence, so it will execute all the function inside this body. And step out. Step out. Right now it's step out. I teach you such a simple coding because I understand many students they are not familiar with embedded system programming. So I have to teach you from the very beginning. Some students may be already familiar with this kind of programming, but I guess most students are able to have never ever touched this kind of programming. So we need to learn from very simple programming. step by step, and then I will arrange about this time, next time, maybe 3 classes based on MCS 51 to understand some basic techniques needed to design a simple embedded system. After this have finished, I will evaluate everyone, and based on the feedback, I will adjust the next content. Right now, I just plan to use STM32. However, when to use that material depend on your feedback, depend on how you have grasped this content. So we have arranged the homework. I have uploaded to the web station. I will also post it on Facebook. Here's homework. You can find on Chinese web station. There's a teaching material web station. I can share it with you because I found that no one have entered into this web. So I just copy it to chat window. I put it in the chat window, so you can download it. And also, I have established a Facebook page, web page, so you can find it on Facebook. Facebook web page is listed here. Okay, I share with you the Facebook. Right now, only about 10 people, 10 students are in this group. So I share with you, then you can enter Facebook.我跑出来了，我还在里面吗？我在里面的，我怎么会有这个的？啊，那，等一下，我发给他们。好了，差不多了啊，结束，停止共享。So today we have almost finished our class, and you can do the homework by yourself, and we will evaluate your homework result and give you some instruction. You can answer question on Facebook, and I will reply you when I log on the Facebook. 好了 ，OK. This class is over. 你说几句吧。好，拜拜。Any question? 那我关掉了啊。那你关掉吧。啊？你不要绑，没关系的。对，不要绑，这个身体重要。
我帮你还得给你搞饭确实。讲到这边给你反应，要他妈的老师，要对接起来。